So the presentation will be given now by Thomas Roos. Thomas is a senior research engineer at the CSIR in the Energy Center, and he holds a master's in mechanical engineering from the University of Stellenbosch. His main interest at the moment, from a professional point of view, is in the economics of renewable hydrogen production in South Africa and the benefits it presents to the country. Thomas, over to you.
Thank you very much. The topic we'd like to discuss today, you've heard a lot about. You've heard it mentioned in the news, you've heard politicians speak about it, you've heard various industry leaders talk about it, but with various different angles. What I'd like to engage with is to look at the view of the common man. Hello, how did we get there? Quite correct. This hydrogen thing, why is it important? What's the deal with it? Didn't we see this movie before? Vaguely remember George Bush, the whole story in Iraq and the IPHE, and then it kind of crashed and burned, right? So how come hydrogen is a thing? Well, I'd like to suggest that it's very current now as a result of several processes which are converging simultaneously. The first is that of climate regulatory and financing pressure. This exists globally, it exists in the EU, and exists in South Africa. Globally, we've had the Paris Agreement. We know about it. The Paris Agreement gave it that one number, that 1.5 degrees that we're trying to chase, which recent news articles are suggesting we might not make. The global environment has also given us finance activism, where we've had young people who are frustrated at the lack of progress in decarbonization and in real movement politically, that they have taken their voices. I would not say that it's Greta Thunberg on her own, but she is a representative. And this then gave a result in finance activism in corporate boards, corporate AGMs, pressure on finance houses to stop investing in fossils, particularly coal, with the result that it's now particularly difficult to finance a new investment in coal. Within the EU, from 2019, we had the European Green Deal. European Green Deal gave us a deadline of 2050, where the Paris Agreement gave us the number of 1.5. Before the European Green Deal, there were some jurisdictions that spoke about 2050, but the European Green Deal really cemented it as this is the deadline by which we've got to be carbon neutral. 2020, the European Union brought out its hydrogen strategy with an ambition of installing 40 gigawatts of electrolyzer capacity inside Europe and a further 40 gigawatts in the neighborhood of Europe. 40 gigawatts is the size of our electrical grid. Finally, in South Africa, we have got the pressure brought about by the Just Energy Transition Partnership. Came about as a result of the COP26 meeting. It was a negotiated settlement, if you like, where these 5 agencies or political groupings will fund us to the tune of 8.5 billion in return for us decarbonizing, that's adding renewables and retiring coal-fired power stations early, having e-mobility and green hydrogen. So that is what is driving things from a policy and climate perspective. Secondly is economics. Renewables are now cheaper than they've ever been. And the crossover point was roughly 2014. It is now cheaper in areas with good renewable resource to use renewables than the incumbent technologies. And that's true in South Africa particularly. Thirdly, and there's a subtlety we really need to nail down. If at all you like YouTube and you watch social media and you have all these interesting voices saying, hydrogen's a hype, it's not going to work, it's a bad idea, and all sorts of clever people telling you why that is. Well, there's something we really need to nail down first. Green hydrogen is a gas made with renewable electricity to separate oxygen from hydrogen in water. So that hydrogen then becomes a fuel. But when you want to decarbonize, your first best option is always to use renewable electricity directly as in an electrified process. For example, mobility. If your car can make the distance on the charge, battery electric vehicle is a better plan. It is cheaper, it's more efficient, all those things. If you need heating, then use a heat pump. Don't use a direct element, for example. Right? But hydrogen is a second best option. But in areas where electricity won't work, it's the only option you have, and it's worth pursuing. Let's explore that. Why would you use hydrogen? You'd first use it if you don't have the renewable resources. Japan is a good example of this. Japan is a geologically unstable country in an unfriendly neighborhood with no natural resources. They're in the top 3 importers of the energy vectors, coal, oil, and natural gas. Top 3 in the world. They have no energy security. Their last chance at energy security was blown when Fukushima happened and public acceptance of nuclear tanked. So now hydrogen is a way of doing that. We'll explore Japan in a little while. The other area is in hard-to-abate sectors. And hard-to-abate sectors fall into 2 distinct categories. Long-distance heavy transport, commercial aviation, maritime shipping, and long-distance heavy trucking. These are not options that you can do with a battery. The second is chemical industries of various kinds. Iron making, in order to make steel, you've got to strip out the oxygen out of iron oxide to leave iron behind. We currently do that with carbon monoxide. If you replace your carbon monoxide with hydrogen, you do it in a carbon-free way. Cement produces CO2 as part of natural process of its manufacture. Ammonia is used in fertilizers around the world, explosives, it's a refrigerant. It's used as a chemical input for a number of different processes. And almost everywhere it's made with hydrogen made by steam reforming of methane, except in China where they do it with gasification of coal. Finally, plastics. Plastics might very well, together with sustainable aviation fuels and certain marine fuels, be the only allowable hydrocarbons in a post-Paris world. You see your image there, showing you where everything fits in. I have rail as a special case, because we know you can electrify rail, right? You build a rail and it's Pantechnicon thingy that gets the electricity from the overhead line. But if you've got a significant part of your rail network that is not electrified, retrofitting that electrification is prohibitively expensive. And the European Union has determined that for rail lines longer than 100 kilometers or rail lines with fewer than 10 trains per day, it is cheaper to run with a hydrogen fuel cell than to electrify that line. So I've covered all this, and it's in gray, so you're not tempted to go back there again. Finally, what's really is the kicker is the public policy support for hydrogen imports, or PTX, or power to X. These are derivatives made with green hydrogen. It began with Japan. In 2014, they determined, look, they pretty much nailed anyway, right, because of the Fukushima. So they said, and they were the initiators of Kyoto. Kyoto is in Japan, but they can't meet their own obligations. So they took a distinctly eastern line. They said, fine, we can't do this, so we'll make it the supplier country's problem. Do what you need to do. We just want the hydrogen. Carbon's on you. And they want to import 300,000 tons of green hydrogen from 2030 onwards at a target price landed in Japan of $3 per kilogram. Germany, their national hydrogen strategy released in 2020, determined that they will need between 2.7 and 3.3 million tons of hydrogen per year to meet their decarbonization goals. But they can only make slightly more than 10% of that in country. They need to import the remainder, much as they do currently with oil and natural gas and so on. So it was going to come from South Europe, Portugal, Spain. Ukraine was the plan. Ukraine is a bit engaged at the moment. So the alternative is to go to countries with renewable rich resources that are also simultaneously in a development relationship with Germany. South Africa meets both those requirements. Finally, the invasion of Ukraine, you would have thought, would have made Europe scale back on their ambition. It didn't. It accelerated it. And as a result of that, they want an additional 10 million tons per year of green hydrogen. That's a big market. Have a look at this map. The redder it is, the cheaper you can make the hydrogen. And it's a function of solar and wind together. The reason for that is an electrolyzer that thing which takes the electricity through which you pass through water and separate in oxygen and hydrogen, that's a high capex unit. It's expensive. If you only use it a few hours a year, you're going to make expensive hydrogen. So you want it to run as long as you can. So therefore, you want sun by day and you want wind by night. This gives you an idea of where things can happen. So we are pretty competitive for a coastal country. And coastal is important because we want to export the stuff. We want to export sunshine and wind. And this gives us an economic opportunity. Regarding the drivers further, we say there's a hydrogen market. But what does that mean? There are actually 3 hydrogen markets, and they behave very differently. And it's important for us to understand this. The export market we've described briefly, right? According to the IHS market study, South Africa can capture between 7 and 12% of the global hydrogen market. Now, this means that you can get a long-term offtake agreement from a sovereign, could be a sovereign nation, it could be a company, it could be something of that nature. That then, because of that security, you can then secure cheap financing, which is critical because you've got a lot of capex in the ground for a long time. You need cheap financing, and you can build at scale. If you build at scale, the unit costs are lower. So you have lower first costs, which means you can have excess green hydrogen available for our own market. We get a lot of comments, people saying, why are you selling it to Europe? We've got our own people, and we don't have power, and we have load shedding, and all this sort of stuff. All good questions. We will address them in turn. You don't just have to export hydrogen as a gas or as ammonia. You can export it as iron or steel. I remember I mentioned earlier that to strip out the oxygen out of iron oxide, you can then export the raw iron. ArcelorMittal has Saldanha Steel, 1.5 million ton per year facility in Saldanha. It was closed because it couldn't compete with cheap Chinese steel. But it couldn't compete with cheap Chinese grey steel. But if it was restarted, it would compete pretty well with green European steel. And so that's the proper question to ask. So we take South African sunshine and wind and turn that into green iron and steel. But we don't export steel to Europe. And the reason we don't export steel to Europe is because every country looks after its own steel market. And if we, as a result of exporting our steel, result in European job losses, politically that's a non-starter. So we don't go all the way to steel. We just stop a little bit short and we make it iron. They take the iron, they make steel according to their own recipe, whether it's high vanadium or stainless steel or whatever, and then make their products. No European jobs are lost, happiness all round, right? Problem. The European steel market, they don't know where they fit in the international merit order. Are they important, more important than transport, so they'll always get their green hydrogen, or are they least important, and transport's always going to get in the queue first? If you're making batch-wise steel process with a blast oven gas, it's not a problem. But if you're going to make it with hydrogen, it's a continuous process. You can't tolerate a hydrogen interruption. So, if in South Africa, they can offshore some of their energy-intensive operation to South Africa, they actually address some of their risk. And we benefit because we get large volumes. Cool deal. Okay, that's the export market. Then there's the local market, right? You often hear people say, oh, we're going to decarbonize the local market, we're going to decarbonize heavy transport, happiness, all good stuff. But there's a problem. It's more difficult to get scale in South Africa because you need a customer that's going to buy in large volumes. And he's going to be buying at a price much higher than the conventional incumbent technology, being diesel or whatever that is. These customers aren't many. And so probably your launch customers are going to be those customers where their cost is not completely taken up in fuel, where fuel is only a fraction of their costs, but fuel is 100% of their emissions. And here platinum mines are a good example. They're under pressure to decarbonize. So by taking out their diesel and replacing it with hydrogen, they may treble their fuel costs, but they eliminate their carbon emissions, but they don't treble their total operational costs, only the fuel costs. It's more difficult if you're a logistics company. If you run trucks, heavy 18-wheelers, and you're moving things from Cape Town to Joburg, right? If you treble your fuel costs, you don't have a business proposition anymore. So who pays the difference? I'm not saying we shouldn't do it. I'm saying it's a problem, and we need to find a way of making that work. So you've got an export market, you've got an import, you've got a local market. But there's a third market, and that's the border market. Wêreld, 36 seconds. And the border market is where the customer comes to you, to your border. And these are vessels that call at South African ports or aircraft that call at South African airports. The Sasol, particularly keen on doing sustainable aviation fuel. They're the only company in the world that have a Fischer-Tropsch process that is Federal Aviation Authority certified. For shipping, for large vessels, calling it South Africa, for Saldanha and Cape Town together, for vessels, if they convert to green hydrogen, will need 500,000 tons of hydrogen per year. That's 2/3 more than the entire demand of Japan. For Kucha and Port Elizabeth, 247,000 tons. Half of that, but still a nice sum. The Hydrogen Society roadmap responds to this in different ways. Regarding the export market, they reference the various possibilities. Sorry, I'm supposed to stop now. Japan, Germany, and the EU target of 2% of global market at 2050 is given, and the Buchuba is given as the main export port. The other ports are mentioned but not emphasized. The border market aviation is highlighted, but the shipping is discussed, but only in the point of decarbonizing transport, not in terms of a market in its own right. And in the local market, Platinum Valley and the Coal-to-X project. Border markets are difficult. You're in international waters. There's no compliance. Your only compliance regimen is the IMO. The IMO is the one organization in the world with the lowest climate ambition. They only want to decarbonize by 50% by 2050. But at least they have a target, and there's a possibility there. There are 3 ways in which you can decarbonize shipping. The vessels can do it voluntarily, and CMB and Maersk are doing that already. The Clydebank Declaration allows you to set up green corridors between 2 ports and a defined cargo. We can discuss that afterwards because I'm running out of time. And if you're going to ship green hydrogen overseas, you also want your vessel to be running on green hydrogen-derived products. Otherwise, you've not decarbonized the whole value chain. We've got a number of current activities in shipping. The World Bank is doing a study for the the Presidential Climate Commission, specifically looking at Buchuba and Saldanha Bay to create green fuels for shipping. The Norway IMO Green Voyage Project, that was discussed at the World Maritime Day parallel event in Durban. And the Department of Transport Maritime Industry Task Force, number 6, specifically looks at decarbonizing shipping. In terms of financing, who's been paying for all this? KfW made €200 million available to finance green hydrogen projects in South Africa. The Industrial Development Corporation is partnering with KfW in all those individual projects. There were 55 submissions, 20 projects in the long list, short list of 12. So there's a lot of appetite from industry. They're ready to play. And the European Investment Bank has a purse of 1 billion as opposed to 200,000 euro. Okay, not all of that in hydrogen, but it's all in transition-related stuff. And they want to make 500 million euro, not rand, available for Transnet and able to decarbonize their operations. Finally, the World Bank is funding that sustainable bunker fuel, as I spoke about. Apart from banks, there are other agencies funding activities. European Union delegation in South Africa, their purse is small, but it's insightful. And they've already catalyzed a lot of really good work. GIZ, the German development agency, is funding the H2SA family of projects for which presidency is the political principle. There's the PTX pathway study, where DTIC is the political principle, where we'll be looking at 7 southern African ports and comparing them for green hydrogen costs, and 3 inland sites. They also fund a lot of capacity building. And then there's the IMO. Finally, in CSIR, we have the chemicals cluster. And this is led by Jan. And they do specifically hydrogen generation, storage, distribution codes and standards. The Energy Center, where I'm from, we do business cases and economics of green hydrogen production. Grid and energy master plans. We look at the just energy transition. Other groups are looking at mobility, heavy vehicles and specialist vehicles. Environmental management services are looking at just what they did for the grid with renewable zone areas. We need to do the same for green hydrogen because the port is not always near a renewable zone. That's particularly true for Richards Bay. The National Cleaner Production Center, they typically make training available for industries and SMEs. And that's normally energy efficiency and waste. They're now moving towards green hydrogen. And finally, CSIR as a whole is developing an organization-wide strategy. I thank you for your attention.